During the Ice Age, even the smallest sound could put you in danger. This was a world where humans were not the hunters. They were prey. So if humans were not the ones in control, who truly ruled this ancient landscape? And before we begin, let us know where you're watching from. Who knows, your hometown may once have been home to some of these ancient creatures. This is East Africa, around 2.6 million years ago. The Ice Age had begun, but this was not the frozen world many people imagine today. East Africa was becoming drier, with vast savannas stretching across the landscape. Scattered trees, dense thickets, and seasonal rivers shaped the land. These changing environments supported an extraordinary variety of life. Herds of ancient antelopes and early zebras moved constantly in search of fresh vegetation. Countless species had adapted to survive in this ever-changing world, each occupying its own ecological niche. Even among the species that shared this world was one that would eventually change the course of history. It was Homo habilis. They walked upright and had already begun making some of the earliest known stone tools. Much of their day was spent searching for roots, fruits, insects, and any scraps of meat they could find. But they were not yet powerful hunters, nor were they at the top of the food web. For many large predators, Homo habilis was simply another animal moving through the African savanna. While a small group was searching for food among the grass and dense brush, another pair of eyes may have been watching from nearby. One moment of distraction, and a surprise attack began. And it was Dinofelis. An early saber-toothed cat that lived across much of eastern and southern Africa. It was not the largest saber-toothed predator that ever existed, measuring roughly 5 feet or about 1.5 meters in body length. Its true advantage came from something else. Dinofelis had a powerfully built body, broad shoulders, and exceptionally muscular forelimbs. Despite carrying impressive saber teeth, its most dangerous weapon wasn't its bite. It was the few seconds before the attack even began. Many animals may never have realized Dinofelis was there until its claws were already holding them down. Yet there's one fascinating fact: Dinofelis didn't chase down prey the way cheetahs or modern lions do. So how did it bring down animals large enough to sustain itself? The answer lay in its hunting strategy. It relied on ambush. Dense vegetation and woodland edges provided excellent cover. Dinofelis could remain hidden until an animal came within striking distance. Then, in a sudden burst of speed, it lunged forward. Its powerful forelimbs seized and restrained the prey, while its elongated canine teeth delivered a precise bite to vulnerable areas such as the neck. Rather than winning through endurance, Dinofelis relied on surprise strength and close-range control. This strategy made it especially effective in the wooded and bush-filled habitats of early Pleistocene Africa. Wild pigs, ancient antelopes, and other medium-sized mammals were likely among its usual prey. But on occasion, our own early ancestors may also have fallen within its sights. No one can directly witness those encounters today, yet the fossil record preserves intriguing clues. Several prehistoric hominin fossils discovered in South Africa bear tooth marks that closely match those left by large prehistoric cats. Based on the size and pattern of these marks, many researchers consider Dinofelis one of the strongest candidates responsible for at least some attacks on early hominins. These findings make the possibility that prehistoric humans also became prey far more compelling. There was a time when humans were not the dominant species in their environment. They were part of a much larger food web. During the early Ice Age, surviving on the African savanna meant more than simply finding food. It also meant avoiding becoming food yourself. A group of Homo may have managed to leave one predator behind. But that raises another question. Had they truly escaped? Not necessarily. The Pleistocene was not defined by a single master predator. Instead, it was home to a diverse array of hunters, each specialized for different landscapes and survival strategies. Navigating this world meant that escaping one threat often led directly into the territory of another. One of those predators was Megantereon, an early saber-toothed cat found across Africa, Europe, and parts of Asia. Megantereon appears to have been better adapted to more open environments than Dinofelis. It was not built for long-distance pursuit. Instead, its broad shoulders, heavily muscled neck, powerful forelimbs, and elongated saber-like canines reveal an animal specialized for sudden, close-range attacks. Concealment, explosive strength, and precision were the foundations of its hunting strategy. Megantereon belonged to the same evolutionary lineage that would later give rise to the famous Smilodon. Long before this iconic saber-toothed cat appeared in the Americas, its ancestors had already developed the specialized hunting techniques that made saber-toothed cats so successful across the Old World. For Homo erectus, that meant the landscape itself offered no guarantees of safety. Open woodland, scattered shrubs, riverbanks, and grassy clearings could all conceal different kinds of predators. Escaping one hunter did not mean the danger had passed. It simply meant the next encounter might come from somewhere else. This is perhaps the most important lesson the Ice Age teaches us. Early humans did not survive in a world dominated by a single apex predator. They lived among many, each adapted to exploit different opportunities within the same ecosystem. In such a world, survival demanded constant vigilance, careful decisions, and the ability to recognize danger before it was too late. Escaping predators was only one part of survival. Even after avoiding becoming prey, early humans still faced another constant challenge: finding enough food. A large carcass could sustain an entire group for days, providing meat, fat, and nutrient-rich marrow. But in the early Pleistocene, a carcass rarely belonged to whoever found it first. It belonged to whoever could defend it. If early humans managed to reach a carcass before other predators, what could possibly take it away? Part of the answer lies in a giant hyena, Pachycrocuta brevirostris. Its name reflects the extraordinary strength of its jaws. Equipped with massive jaw muscles and robust crushing teeth, Pachycrocuta could crack open the enormous limb bones of horses, ancient bovids, and even elephants. Bones, teeth, and even skulls could be reduced to fragments, allowing it to extract nutrients that few other animals could reach. Very little of a carcass was left behind. For this reason, Pachycrocuta is often described as one of the most efficient bone-crushing scavengers ever to evolve. Unlike ambush predators that relied primarily on bringing down live prey, Pachycrocuta frequently capitalized on feeding opportunities created by other predators. Thanks to its immense size and strong social behavior, it could drive competing animals away and seize valuable food resources. For many Ice Age predators, the hunt was only half the battle. Holding onto a carcass was often just as difficult, and giant hyenas were among the most formidable competitors waiting to claim it. For early humans, this created a very different kind of danger. Pachycrocuta was probably not roaming the landscape in search of people. Early hominins were relatively small, offered limited food, and were unlikely to be the easiest prey available. The real conflict was more likely over something both species desperately needed: food. A carcass that could keep a group of Homo habilis alive for several days represented exactly the same valuable resource for a clan of giant hyenas. When both arrived at the same place, confrontation may have become unavoidable. Fossil evidence also suggests that Pachycrocuta and early members of the genus Homo sometimes competed for the same carcasses. Whenever both reached the same food source, each faced the challenge of securing enough resources to survive. This reveals another harsh reality of the Ice Age. Surviving was not simply about avoiding predators. Sometimes the greatest struggle began only after food had been found. Because during the Pleistocene, survival meant more than just avoiding danger. It was a constant struggle to secure energy in a world where even finding a meal was never truly safe. By this time, prehistoric humans had realized that the Ice Age offered very few safe places. Grass wasn't safe. Food wasn't safe. But perhaps the most dangerous place wasn't hidden among the savanna meadows. It was the place every living creature was forced to go water. Across East Africa, rivers, lakes, and seasonal waterholes became gathering points for life itself. Herds of ancient antelopes arrived to drink. Early zebras moved toward the shoreline. Large herbivores crossed the open plains in search of fresh water, while scavengers searched for carcasses along the riverbanks. And Homo habilis had no choice but to come as well. No matter how dangerous the landscape became, they still needed water every single day. But predators understood this better than anyone. Where prey gathered, opportunities followed. And beneath the calm surface of these rivers waited one of the most formidable reptiles ever to share the landscape with our ancestors, Crocodylus anthropophagus. Its name comes from Greek and literally means human-eating crocodile. It is one of the very few prehistoric animals whose scientific name was inspired by evidence suggesting interactions with ancient humans. This giant crocodile could reach lengths of up to 25 feet, nearly double the length of a modern family car, and significantly larger than most crocodile species found in Africa today. Yet its greatest advantage was not simply its size, it was patience. Unlike the saber-toothed cats that relied on vegetation for cover, Crocodylus anthropophagus used water itself as a hunting tool. Almost its entire body remained hidden beneath the surface. Only its eyes and nostrils were visible above the waterline, allowing it to remain nearly impossible to detect. For a thirsty animal approaching the riverbank, there was often no warning at all. A single step too close to the edge could become a dangerous mistake. Scientists have discovered hominin fossils at Olduvai Gorge in Tanzania, bearing tooth marks that closely match the spacing and dimensions of the teeth of Crocodylus anthropophagus. While no one can witness these encounters today, the fossil evidence strongly suggests that early humans occasionally fell within the range of this ancient predator. That meant our ancestors faced a harsh reality. They had to survive in an environment where danger was always present. Yet the rivers were only one part of the vast Ice Age world. Beyond them lay open plains, woodlands, and wetlands inhabited by animals so immense that their presence alone could shape the movements of everything around them. Not every challenge of the Ice Age came from an animal that hunted. Some came from creatures whose size and behavior transformed the landscape into an obstacle of its own. Across the Pleistocene, some of the largest mammals ever to walk the earth shared these environments with our ancestors. Among them was Palaeoloxodon antiquus, the straight-tusked elephant. Reaching more than 25 feet in length, it was one of the largest land mammals of its time. Nearby lived Hippopotamus gorgops, an ancient hippopotamus recognized by its unusually elevated eye sockets, an adaptation that allowed it to keep most of its body submerged while watching everything around it. Neither species relied on hunting early humans. They had little reason to, yet that did not make them harmless. A herd of giant elephants could block the safest route across the landscape for hours. while an enormous hippo defending a riverbank could make the only nearby water source impossible to reach. For a small group of Homo habilis, these encounters often meant turning back, taking a longer route, or waiting until the animals finally moved on. Every detour costs valuable time, every extra mile demanded precious energy, and every delay increased the chance of crossing paths with predators once again. Survival was shaped not only by the animals that hunted our ancestors, but also by those powerful enough to reshape the landscape simply through their presence. For early humans, knowing when to step aside may have been just as important as knowing when to run. Because in the prehistoric world, not every giant was a predator. Yet even giants could determine where our ancestors walked, where they found water, and ultimately, whether they survived another day. But animals were only part of the story. Another force, far greater than any predator or giant mammal, was beginning to transform the world itself: the climate. The Ice Age was never a world that stood still. Across Africa, the climate gradually became drier. Rainfall declined, and longer dry seasons caused dense forests and woodlands to retreat. Vast savannas and open grasslands spread across the landscape. Rivers dried up, seasonal lakes disappeared during the driest years, and familiar habitats were transformed. For many of the prehistoric animals that once dominated these ancient landscapes, adaptation became increasingly difficult. Highly specialized hunters, such as Dinofelis, gradually disappeared from the fossil record. Megantereon, one of the world's most iconic saber-toothed cats, also faded away as environments continued to change. Even the giant bone-crushing hyena Pachycrocuta brevirostris eventually vanished after millions of years of success. Yet the story did not end with their disappearance. Although these extraordinary species no longer walk the earth, many of their relatives still do. Crocodiles remain patient ambush hunters along African rivers, using a strategy that has changed surprisingly little for millions of years. Modern lions, leopards, and cheetahs continue the long evolutionary history of Africa's great cats. Today's spotted hyenas still inherit the remarkably powerful jaws that made their ancient relatives famous. The landscapes have changed. The faces have changed. But many of the roles remain the same. The balance between predator and prey, between competition and survival, continues to shape life across the planet, just as it did millions of years ago. Our own ancestors were changing as well. Instead of evolving larger bodies, longer claws, or more powerful jaws, they followed a very different evolutionary path. Their hands became increasingly skillful. Stone tools grew more sophisticated with each generation. Cooperation became stronger, allowing small groups to share food, protect one another, and care for their young more effectively. Communication also became increasingly complex, making it possible to pass knowledge from one generation to the next. Unlike instinct alone, learned experience could accumulate over time. Every generation inherited not only its genes, but also the discoveries, skills, and survival strategies of those who came before. Over thousands of generations, these gradual changes eventually gave rise to modern humans, including all of us today. Rather than simply adapting to changing environments, humans eventually learned to investigate them. Through archaeology, paleontology, and countless scientific discoveries, we have reconstructed ecosystems that vanished millions of years ago. The fossilized bones of Dinofelis, Megantereon, Pachycrocuta, and countless other prehistoric animals reveal a world that no human ever witnessed firsthand. These discoveries remind us that our ancestors once occupied a very different place in nature. They lived among formidable predators, competed for limited food, and survived only by adapting to constantly changing environments. From those uncertain beginnings emerged a species capable of exploring every continent, uncovering the history of life, and tracing the evolutionary relationships connecting extinct animals with the living world around us. The Ice Age eventually came to an end, but its legacy never disappeared. It remains preserved in the rocks beneath our feet, in fossils buried within ancient sediments in landscapes shaped by ancient climates, and even in the descendants of species that survived those dramatic environmental changes. Every new discovery adds another piece to Earth's long history, revealing how shifting climates, evolving ecosystems, and millions of years of evolution shaped the planet we know today. The story of the Ice Age is therefore not only about creatures that disappeared, but also about the enduring connections that continue to link every living species to Earth's deep past. But the Ice Age was only one chapter of prehistory. Many more ancient worlds are still waiting to be explored. The prehistoric Amazon alone holds countless mysteries that have yet to be uncovered. So be sure to subscribe and join us on our next adventure. Thank you for watching, and we'll see you in the next video.
Imagine this. You're trying to put together a massive jigsaw puzzle with thousands of pieces, but there's no instruction manual, and some pieces were lost forever. That's essentially what paleontologists do every day. Paleontology is an incredibly challenging field. Scientists are trying to reconstruct entire organisms using only fossilized remains, often incomplete, extremely fragile, or dating back hundreds of millions of years. Sometimes they're dealing with all of those limitations at once. Calling this work difficult hardly does it justice. Given these obstacles, it's no surprise that mistakes have happened over time. Most are minor and fairly understandable, like overestimating an animal's size or misinterpreting small details. But occasionally an error is far more significant, so impactful that it reshapes how we view an entire species and leaves researchers puzzled. And that's exactly what we'll see with these 7 fascinating creatures. And to understand just how far off early ideas could be, we have to start at the very beginning with the first dinosaur ever named. In 1824, the English scientist William Buckland described a creature called Megalosaurus based on only a handful of fossil bones. What he imagined was not the fast-moving predator we know today, but a massive, heavy lizard. He believed it walked on 4 legs, spent much of its time in water, and resembled something closer to a crocodile than a dinosaur. At the time, scientific thinking was still closely tied to religious ideas. Buckland even believed that Megalosaurus wasn't a vicious predator. Instead, he thought this giant creature actually helped reduce suffering in nature by quickly ending the lives of the old and weak animals. It was an attempt to make sense of a violent prehistoric world using the beliefs of his era. Some early estimates even pushed its length far beyond what we now consider possible. But as more fossils were discovered, the picture began to change. Scientists realized that Megalosaurus was actually a 2-legged predator. It lived on land, not in water, and measured around 9 meters in length. It was still impressive, but very different from the original vision. Despite all the early confusion, Megalosaurus played a crucial role in science. In 1842, the paleontologist Richard Owen studied it alongside other large fossils and recognized that these animals formed a completely new group. He named that group Dinosauria. So even though Megalosaurus was misunderstood, it helped define what dinosaurs actually are. This story reveals something important. Science works with fragments, and sometimes those fragments can lead us in the wrong direction until better evidence comes along. And from the very first dinosaur, we now move to a creature that captured the world's imagination for decades, a giant spider that was never really a spider at all. In the 1980s, a fossil discovered in Argentina was identified as a massive prehistoric spider. It was given the name Megarachne, meaning great spider. Based on the limited material available at the time, scientists estimated it could reach about 13 inches across. That would have made it larger than any spider known to have ever lived. The idea quickly spread. Megarachne appeared in books, museum exhibits, and documentaries. For many people, it became the ultimate nightmare creature, a giant spider from deep time. And because it came from the Carboniferous period, a time known for oversized arthropods, the interpretation seemed to make sense. But there were problems. Some features of the fossil did not match any known spider anatomy. The body structure looked unusual. The front part of the body appeared divided in a way not seen in true spiders. What scientists thought were fangs did not fully match real spider fangs, which are sharp and specialized for injecting venom. Still, without better evidence, those concerns were mostly set aside. The real breakthrough came in 2005, when a more complete specimen was discovered. This new fossil preserved clearer limbs and body segments, showing paddle-like appendages suited for swimming rather than walking. It was actually a eurypterid, an extinct group of aquatic arthropods often called sea scorpions. Some lived in fresh water, not the ocean. Instead of crawling on land, this animal likely lived in shallow water. It probably used its limbs to sift through sediment and feed on small organisms. The giant spider never existed. It was a case of mistaken identity that lasted for more than 20 years. As we continue from that earlier story where fragments led even the best minds astray, the next case may be one of the strangest misinterpretations in paleontology history. In the late 1940s, Soviet paleontologist Ivan Efremov uncovered a set of enormous claws in the Gobi Desert. He had only a few ribs, part of a hand, and 3 enormous claws. Each claw measured close to 3 feet in length. With such limited evidence, Maliv offered the best explanation he could. He argued that no known terrestrial animal possessed claws of that shape. These claws resembled those of turtles and may have been used to cut underwater vegetation or serve some specialized feeding function. Therefore, he believed the remains belonged to a giant turtle-like reptile and named it Therizinosaurus cheloniformis. It was imagined as a strange aquatic creature living alongside dinosaurs like hadrosaurs and Tyrannosaurus. That interpretation lasted for years until a major reanalysis in 1970 by Anatoly Rojdestvensky. He discovered that the fossils had been misread. The ribs likely belonged to a long-necked dinosaur, while the hand and claws came from a completely different animal, an unknown type of theropod. Suddenly, the mystery deepened. What kind of theropod had such enormous claws, and what were they used for? The answer began to emerge when more complete fossils were described in 1976 by Rinchen Barsbold. It was recognized as a highly unusual theropod dinosaur. It possessed a massive body, a long neck, and a small head. However, its most distinctive feature was its enormous forelimbs, each ending in 3 elongated claws that could exceed 1 meter in length. Despite belonging to the same broader group as predators like Tyrannosaurus rex, this dinosaur likely had a very different lifestyle. Evidence suggests it was primarily herbivorous, using its claws to pull down branches, strip leaves, or defend itself against predators. What was once thought to be a giant turtle-like creature is now understood as one of the strangest dinosaurs ever discovered. It was a slow-moving, plant-eating giant armed with some of the longest claws in the history of life on land. Recent discoveries have added even more detail. In 2025, scientists described a related species called Duonychus tsogtbatari, preserving rare keratin sheaths over its claws. Compared to what we see in the fossils, their claws were actually even longer in life. That finding suggests they were likely adapted more for reach and feeding, rather than being primarily used for digging or combat. And from these clawed giants of the desert, we now turn to creatures of the sky once mistaken for the sea. In the late 18th century, the first fossils of Pterodactylus were discovered in limestone deposits in Bavaria, Germany. At the time, scientists had never seen anything like them. The long fingers, the thin bones, and the wing-like structures were deeply confusing. The Italian naturalist Cosimo Alessandro Collini described it as a marine creature, believing the wing structures were actually long flippers used to swim underwater. He even suggested it lived entirely in the sea. Others proposed slightly different ideas. Some thought it might be amphibious, living both on land and in water, much like a seal. At the time, there was no clear agreement on whether it was a reptile, a mammal, or something entirely unknown. This led researchers like Georges Cuvier to recognize it as a flying reptile. By 1809, it was formally described and named, meaning winged finger. From that point on, an entirely new picture came into focus. This prehistoric creature lived during the late Jurassic period, approximately 150 million years ago, in what is now Europe. It featured a long snout filled with dozens of small pointed teeth, perfect for catching small prey. Their lightweight, hollow bones and skin membrane wings allowed them to be agile flyers, perfectly adapted for survival in ancient marine ecosystems. It likely fed on small animals and fish, staying close to water, but not living as a deep diving swimmer. But as strange as the idea of a swimming reptile may sound, some other mistakes are far more complex. If mistaking one animal for another sounds like a big error, what happens when scientists mistake one animal for three completely different creatures? That is exactly what happened with Anomalocaris, one of the strangest animals ever discovered. This creature lived during the Cambrian period, a time when complex life was just beginning to take shape. It was unusually large for its time, reaching lengths of about 3 feet, and it is now considered one of the largest predators of its time. Its body plan looked so unusual that even today it still surprises people. The confusion began in the late 19th century, when fossils were first uncovered in the famous Burgess Shale. Researchers discovered several strange fossils lying close together. Some featured elongated, tapered, and segmented bodies. Others possessed spiny front appendages that resembled shrimp, while some revealed a circular mouth that looked almost like a jellyfish. Given how distinct each fragment appeared, researchers initially classified them as 3 unrelated species. Since these parts were found close together, the assumption seemed reasonable at the time. However, these distinct creatures kept showing up together. Eventually, researchers realized the obvious answer. All of these parts belonged to a single animal. By the 1970s, scientists finally reconstructed the full animal. Anomalocaris emerged as a member of the radiodont group, an early branch of arthropod relatives. This prehistoric creature swam swiftly, using its tentacles to grasp and handle prey with precision. It took nearly a century for the puzzle pieces to fit, but once they did, Anomalocaris went from a collection of errors to the undisputed, terrifying apex predator of the Cambrian seas. As it turns out, having all the pieces of the puzzle in one place doesn't guarantee you'll put them together correctly. In fact, even with a complete skeleton, scientists can still get a crucial detail horribly wrong. As the bizarre story of Dinotherium clearly shows, this prehistoric animal was a relative of modern elephants. It lived from the Miocene to the Pliocene and could stand over 10 to 13 feet tall at the shoulder. At first glance, it's easy to see why they were known as the terrible beast. But the real confusion did not come from its size. It came from its anatomy. Early reconstructions struggled to make sense of its unusual skull. Dinotherium had a pair of large tusks that curved downward from the lower jaw, not upward from the upper jaw like modern elephants. Because this arrangement was so unfamiliar, early researchers struggled to interpret how the tusks were used and positioned. The confusion did not stop there. Some scientists proposed that it might have been semi-aquatic, living partly in water like a hippopotamus. Others even imagined it as a sea elephant, though this was largely speculative. Its trunk was also misunderstood, often reconstructed as long and similar to that of modern elephants. But in reality, the evidence suggests it may have been shorter, more like the trunk of a tapir. Over time, more complete fossils helped clarify the picture. Dinotherium was a land-dwelling herbivore. Its downward curving tusks were likely used to pull down branches or strip vegetation and possibly to dig for roots. Rather than a strange aquatic creature, it was a specialized browser, perfectly adapted to its environment. Today, modern reconstructions have corrected these earlier mistakes, offering a far more accurate image of this remarkable animal. After so many cases where scientists got these animals wrong, this final story is even more surprising. A creature we believed had disappeared entirely, the coelacanth. In paleontology, mistakes do not only come from misreading fossils. Sometimes they come from what we do not find. There is even a term for this, a Lazarus taxon used to describe species that vanish from the fossil record and later reappear. The coelacanth is the most famous example. For a long time, these fish were known only from ancient rocks. Fossils dating back more than 250 million years were found across different periods, showing that coelacanths once lived for an incredibly long span of time. Then suddenly they seemed to disappear. Around 66 million years ago, at the same time as the non-avian dinosaurs. For decades, scientists believed they had gone extinct. The specimen was covered in thick, armor-like scales with fins that looked almost like limbs. It was unlike anything the fishermen had ever seen. When the specimen was studied by James Leonard Brierly Smith, the realization was immediate. This was a living coelacanth, a species thought to have vanished with the dinosaurs. The discovery shocked the world and led to further expeditions. Scientists later identified a second species, Latimeria menadoensis, living in deep waters of Indonesia. These fish can grow over 6 feet long, weigh close to 200 pounds, and may live for many decades. In recent years, researchers have managed to capture rare footage of the Indonesian species Latimeria menadoensis in its natural habitat at depths of around 475 feet, offering a glimpse into a world we still barely understand. In the end, this story says everything. Science works with fragments, and sometimes those fragments are missing entirely. And when they finally appear, they can change everything we thought we knew. Science is not always perfect. What truly matters is that it keeps improving and never stops learning. And that idea still applies today. Even now, scientists continue to question old assumptions and refine what we think we know about the world. Which is why your perspective matters too. So which of these cases surprised you the most? Please leave a comment below. Thank you for watching, and see you next time on Fastra Science.